Hi, Hari, Jeff, and Murli. We'll wait
Hi,
for
sir.
people to join, okay, and then we'll start in some time.
Yes.
Let's wait for 5 to 10 minutes, and we'll see. Okay.
Okay.
And meanwhile, you can
Okay.
find out doubts, and we exercise 8.1 was homework, right? Have you tried that? See, those problems you weren't able to solve it. We'll discuss it today. Okay. Hello. Okay. We'll start in some time. Let others join. Shall we wait or shall we start? Srinidhi, okay, you guys are here. So we'll start, okay? So I'll share my screen. Let me know if you are able to see. See, I'm not host right now. I'll have to talk to Bhaskar. Just wait for a minute. Hi, Raghav. Actually, Vidisha is not receiving call. Can you make me that? Give me the host. Make me the host. Thanks. Uh, Guys, please wait for like 1 or 2 minutes
Okay,
till I get the access. Oh, okay. So did you try to solve that 8.1 exercise 8.1 problems?
yes, sir.
Okay. How many of the problems you were able to solve?
Sir, about 5, sir.
Okay. So do you have any doubt in any of the problems apart from like 13th and 14th? Because those were
Uh,
I didn't prove. So yeah, tell me.
Sir, 6 to 9, sir, and I mean the
6 to
proofs.
I told you approach now means like
Yeah.
1 to 100 to the power of 100 plus 2 to the power of 5 you could do.
Yes, sir. So, but those 6 to 9, those sums I'm not sure how to do them, sir.
Okay, 6 to 9. We'll see.
Okay, sir.
Anyone else? Six, seven, eight, nine. Anyone else is having that same doubt what Murli is having? Murli, can you just give it a try? Right, 99 this is problem number 9, right? So 99 100 minus 1, you write 99 as 100 minus 1 to the power of 5
Okay, sir.
and use the same binomial theorem. Okay,
Oh,
because
okay,
you
sir.
have A is your 100 and B is 1. So from there,
Oh, okay, sir.
yeah, that's what. No, I told you a method of doing it.
Yes, sir. Yes, sir.
Yeah. Please try that.
Okay, sir.
Yeah. Anyone else? Murli, apart from Murli, Abhinav, Hari, both Hari, Jeffrey, Naveen. Naveen is also here today. Okay. Naveen, did you try? Srinidhi, any doubt? Nidhi, you there? Okay, I'm not able to hear you, but okay. Some messages. Okay, fine. You are not able to unmute. Okay, do it again. Try to. Jeffrey, this is. So you use the same method that we have talked about, and you'll be able to do so. Hari, did you try all the problems? Hari Raghav?
Sir, I didn't try all, sir. I just completed till first one.
You? What?
Sir, I completed up to fifth one, sir. I didn't try six.
Why didn't you try it 6 months? When you will try? How
Sir,
many
I was
days?
having exam, sir. So.
Okay, Hari? Hariharan?
Sir,
Okay, I've got the host ID, so I'll share the screen. So, can you see the screen, everyone?
Yes, sir.
Okay. Okay, I think we were here. So this is where we left, right? See, at last I gave you some suggestion how to solve. Can you see this? Murli,
Yes, sir. Yes, sir. Yes, sir.
you try using this method. Everyone solve this problem first. Everyone solve this one. Question number 9. Everyone solve question number 9 of NCRT. Exercise this 8.1. So you are given 99 to the power of 5. How you will find it? You can write 99. You can write 100 minus 1 to the power of 5. Now this is your A, this is your B, and this is your N. First, always write the binomial theorem. Okay, always write A plus B to the power of N. By the way, B is minus 1, okay, not 1. Now, everyone give it a try. We'll solve it. I'll give you 5 minutes, okay? Not 5 minutes. Let's take 3 minutes, not more than that. Nidhi, you are there? Nidhi, solve it. Naveen, try this problem. Murli. Done?
Sir, almost done, sir. Once again.
Almost, still almost, okay. Jeffrey,
Yes, almost done. So 1 minute.
almost done. Wow, okay, good. First, always write NC 8 plus B to the power of N. Okay, I cannot wait more. So A plus B to the power of N, how do we know we can write? This will be equal to nc0 a to the power of n b to the power of 0. Okay, plus nc1 a to the power of n minus 1 b to the power of 1, and it will keep going on, and the last one will be ncn a to the power of n minus n b to the power of n. So this is what we can write. Now here we have 100 minus 1 to the power of 5. So we can write this as I hope everyone is done. Yeah, so I will just write 5c0 because n is 5, 5c0, 100 to the power of 5 and minus 1 to the power of 0 plus 5c1, a is how much? 100 to the power of 5 minus 1, so it will be 4
Four.
minus 1 to the power of 1 plus 5c2, 100 to the power of 5 minus 2, which is
3.
3, and minus 1 to the power of 2 plus 5c3, 100 to the power of 2 minus 1 cube, okay, plus 5c4, 100 to the power of 1 minus 1 to the power of 4 plus 5c5 into 100 to the power of 0 minus 1 to the power of 5. This we can write 5c1 is how much? 5c1 is how much?
5,
1,
sir.
1,
Aye.
5c0, sorry, 5c0, not 1.
5c0 is 1, sir.
Yeah, 5c0 is 1 multiplied by 100 to the power of 5 will remain 100 to the power of 5. Minus 1 to the power of 0 is what? 1.
Yes, sir.
Okay, so all right. Plus 5c1 is 5, 100 to the power of 4 into minus 1 plus 5c2 is how much? 10, right? 100 to the power of 3, this multiplied. Minus 1 square is how much? 1 plus 5c3 is again 10 into 100 square into minus 1 cube is minus 1 plus 5c4 is again 5 into 100 into minus 1 to the power of 4 is 1. That's right, 1 plus 5c5 is again 1 into 100 to the power of 0 is 1 minus 1 to the power of 5 is minus 1. Okay, now let's write down. So this will become 100 minus 1 to the power of 5 will be equal to so 100 to the power of 5. Okay, and next term will be minus 5. Because why minus? Because see, here you multiply 5 into whatever this is, and this is multiplied by minus 1, so this will be minus. Okay, so minus 5 into 10 to the power of 4, sorry, 100 to the power of 4 plus 10 into 100 to the power of 3 minus, again minus because of that, see, because of this minus, yeah, because minus, here we are multiplying again by minus 1, so minus 1 it will be, this will be. Anyone is having doubt here?
No, sir.
No, sir.
This is easy problem, right? Plus 5 into 100 minus 1. Okay, so this is minus 1. Yeah, so this again you can write, this you can write 500 to the power of 5, right? So you can write as 10 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Minus, even if you don't write it is fine. I don't see the why do you have to write it. 5 into 100 to the power of 4, that means 8 zeros you will write. 1, 2, 3, 4, 5, 6, 7, 8 plus 10 into 10, 100 cube, that means 7 zeros. 1, 1, 2, 3, 4, 5, 6, 7. Again minus this is 5 zeros into 1, so 5 0 1 2 3 4 5. This we have written plus 500 minus 1. So if can you anyone tell me the calculation?
Sir, we can't hear you, sir.
Okay, so you can do that now. You add this, add this, and subtract. So this is 1 0 0. Okay, 1.
So,
Yeah,
can I try?
yeah, right. Of course you can.
950900499.
See 9509, then
000499.
00049.
Yes.
1 2 3 4 5 6 7 8 9. No, I think something is wrong. Is it correct? Okay, I don't know if it is correct or wrong. I'll have to do the let me use. I'll be using the calculator. Okay, please excuse me for that, because usually we don't have these type of problems. Even in exam, if you have these type of problems, hopefully they don't have it. But if you have, you'll get 3 marks at least. You will get for this. Okay, don't forget. So do the calculation. Everyone do the calculation. See, the number that I am getting is 95099004999. This is what I am getting. Anyone else is getting this number? So if you have calculator, you can just check by 99 to the power of how much? 5. Okay, this is correct. Okay, so this is correct. 95099000499. So this is how you have to do this using binomial theorem. And I suppose it's not, it's just the calculation at the end. You can also, you can do the calculation. It's not that tough. It's on pen paper also you can do the calculation. Okay. Acha, how many of you were able to solve question number 11? Just try question number 11. Find a plus b to the power 4 minus a minus b to the power of 4. Find it. Evaluate it using binomial theorem. Do this. I got it. This one, Nidhi.
Yes, sir, got it.
Okay. What's the final answer you got?
8a cube plus 8ab cube.
8
8a cube plus 8ab cube.
plus 8 AB cube.
Sir, it's 8a cube b plus 8ab
8 A cube B.
plus
Yeah.
8ab cube.
8 AB cube. Right?
Yes, sir.
Yeah, this is correct. How many of you got this? Anyone is having doubt in this one? Now using this, you can find, now since we know A plus B to the power 4 minus A minus B to the power of 4 is equal to 8A cube B plus 8AB cube, right? So you have to find root 3 plus root 2 to the power of 4 minus root 3 minus root 2 to the power of 4. Find it out. Find it fast.
Sir, got that, sir. 8a cube.
Yeah. Okay, find it. Yeah, sorry for the disturbance. Some people came in my mind, so I'm really sorry about that. Oh, okay. So how many of you got the answer? Hello? Anybody is there or everyone left?
Sir, yes, sir. Trying, sir.
Yeah. So try. You got
Sir,
this
I'm-
one.
Sir, yes, sir. I got that one, sir. I'm not able to get
So
the.
you just need to substitute the values, right? Here A is this
Yes, sir. Yes, sir.
and B is this. So you just need to substitute. How long it takes?
Yes, sir. I did that, sir.
So how much? What's the value you are getting?
1 second, sir.
Jeffrey, how much you got?
So 40 root 2, sir.
40 root 2.
Yes, sir.
How?
So I calculated.
How did you calculate it? Tell me the steps. What next? What should I write here? Huh? Why you are unmute? You said now you got the answer.
Sir, I was telling, I was muted, sir. That's right. Sorry.
No, you tell me how. What is the next step?
Yes, sir. 8
Uh,
root 6.
root 6. Where from you get root 6?
So from uh, root 3 into
Hmm?
root 3 into root 2, sir.
Root 3 into root 2. Okay. Root 3 into root 2. Fine. Then
Then root 3 square plus root 2 square.
root 3 square. Then
Root 2 square.
root 2 square.
Yes, sir.
Okay. Then
Then
okay. Leave it. Nidhi, is this correct, Nidhi? Hariharan.
Yes, sir.
Hariharan,
No,
is
sir.
this
That's
correct?
not
Okay. Hariharan, tell me correct. How do you solve it?
Sir, can you hear me, sir?
Yeah, I can hear you.
Sir, first 8 into 3, 6 root 3, sir. As
Why
root 3
6?
cube is
Where
equal to
from?
3 root 3. Sorry, sir. Sorry,
Where
sir.
from?
8, and,
Wait.
8 into 3 root 6, sir.
8 into
3 roots, root 6, sir.
3 root 6. Where from you are getting root 6?
It's root 3 into root 2, sir.
Okay, root 3 into root 2. That means, okay, when I'm telling you steps, you have to tell me in steps, okay? See, first is if, take the baby step. Root 3 into root 3 into root 3 into root 2. That's what the meaning is. Plus 8 into root 3 into root 2 into root 2 into root 2. Right? So
Sir.
this will be equal to 8. And if you multiply these two, what you will get? 3.
3.
If you multiply these two, what you will get? Root
6. Root 6.
Yeah. So how you will get 3? Let's write down that as well. Multiplied by root 3 into root 3. So you can write root 9. And root 9 is what? 3. Right? Isn't it?
Sir, yes, sir.
Yeah. Multiplied by root 3 into root 2. So root 3 into root 2 will be root 6.
Root 6.
Plus 8.
Plus,
Yeah. Now similarly here also root 3 into root 2 will be how much? Into root
8
6. Yeah, exactly. This will be 2. Root 2
Sir.
into root 2 will be 2. Yes. So this is what you need to calculate. Here 8 root 6 you can take out common. 8 root 6 you can take common. So if you are taking
3
this
plus 2.
common, so 3 plus 2. Okay.
8
So
root 6 into 5,
yeah,
sir. So it's 40
exactly.
root 6, sir.
Into 5. So that will be your 40 root 6. Got it,
Sir.
Jeffrey?
yes, sir.
Okay. So just everyone, wherever you have made the mistake, just try to solve it. Okay. Okay. So that was question number 11, right? Okay. Let's. I'll solve one of the problem. Question number 13 or 14. Which one do you want me to solve?
13.
Okay. Question number 13. So it says show that 9 to the power of n plus 1 minus 8n minus 9 is divisible by 64. Okay, you have to show that this number is divisible by 64 whenever n is a positive integer. That means when n is a natural number. Positive integer are natural numbers, right? Isn't it? Okay. Positive integers are what? Positive integers are 1, 2, 3, 4, and all. These are positive, and these are also natural numbers, right? So positive integers are natural numbers. Now, if you want this to show as, see, you had a chapter in I think 4th chapter that is called Principle of Mathematical Induction. So these proofs are mostly based on that. Okay, and using similar manner, we have proved actually the binomial theorem, but I haven't proved it here. I think I have not proved the binomial theorem. This one, see, this theorem you can prove using principle of mathematical induction. Okay, it is the 4th chapter of your book, which has been deleted from your curriculum. So again, that's why we haven't done that. So we will try to do it here. Okay. Now using binomial, that means if you want to prove that any number, let's say some number alpha into beta, okay, or alpha beta, any number is divisible by 7. That means when it is divisible by 7, it has to give a natural number as a product. Sorry, as a result, it has to be a natural number, any natural number. And let's say that natural number is k. Okay, k is a natural number. Okay, k is a natural number. That means you can write alpha plus beta or alpha beta or any number, even if it is plus, so you can also write plus, doesn't matter, is equal to 7 times of that value k, right? So it means alpha plus beta is divisible by k. Oh, sorry, 7. Okay, because any if k is any value, let's say 1, 2, 3, 4, any value, that means it is just a multiple of 7. That and which means that alpha plus beta is divisible by 7. Okay, so we'll use this principle and we'll try to prove this. Okay, that means here it means if it is divisible by, if this value, let's say this is some number n, if n is divisible by how much it says, 46, right? 64, sorry, 64. So what we have to show, we need to show that this n is some value which is n is equal to 64 times of k, where k is a natural number. Okay, okay, there n is already present. I'm sorry. Let's say this is L, not k, because sorry, not L, n, because n is already there, right? So this complete equation is L. If L is divisible by 64, that means therefore L should be equal to 64 into k, for k being natural number. Okay, is this in clear, or do we need any explanation for this? Anyone?
The explanations.
What?
So can you explain more?
Okay, you need explanation. Okay, fine. See, any number, if I'm saying this complete is equal to L. Okay, I'm just writing this here. Okay, so any number, let's say 64. 64, we are saying it is divisible by 2. Okay, so when you divide 64 by 2, that is equal to how much you are getting? 32. Okay, 32 is the answer. Okay, that means you can also say, let's say, let's take another example. Let's say if 64, we are saying, is divisible by a number, let's say k, or not k. Okay, divisible by, let's say what? 8. Okay, that means it has to be, now you can write that this is equal to 8. Now 64 by 2, we saw it is how much? 32. 64 by 8, or 64 is it divisible by 4? It is not divisible by 4, right? It's not divisible by 4. Or is it? 4.
No, it is divisible.
Yeah. How much? 20?
24.
24. 24?
Sorry, sir. 26, sir. 26, sir.
26. Okay, so 26. So it is, now you see it is divisible by 2, divisible by 4, divisible by 8. It's been divisible by so many numbers, right? And the multiple and this, that means you can write 64 is equal to 2 times of 32. You can write 64 is equal to 8 times of 8, and 64 is equal to 4 times of 26, right? That
Yes.
means if these are all natural numbers, right? So these are, you can replace it by k. We are just replacing it by some number k, which is a natural number. Okay, so from here you can find the value of k. Okay, now
Yes.
here we can say 64 is a 64 is divisible by 2. Okay, because the product in the product side you have 2 into k, so k can be any natural number. Here you can say 64 is a multiple of 8. Here you can say 64 is a multiple of 4, and because it is being multiplied by a natural number, that means you are getting a perfect division of these numbers. Okay, or we can say perfect multiple of these numbers. Is it clear, or do you need any other explanation?
Understood.
Huh?
Understood.
Are you sure?
Yes, sir.
Okay. Anybody else need any explanation? Please tell me. Or I can try a different method. Okay. If not, then we'll move ahead. This is, it's not working. All right. Now we will use binomial theorem to prove this. Okay. So how do we write binomial theorem for 1 plus x to the power of n? How do we write it? NC0, right?
Sorry, sir.
Plus,
NC0.
yeah, NC1 x to the power NC1 x plus NC2 x square plus NC3 x cube, and so on, right? And the last term you can write NCn x to the power of 0, right? X to the power of n, sorry, x to the power of n. You get it, because 1 to the power of anything will be just 1, right? So that's why we are not writing it here. You have a proof, by the way, of this. You can prove it using a plus b to the power of n. Just substitute a is equal to 1 and b is equal to x. You will get that. Okay. Okay. Yes or no?
Yes, sir.
All right. Okay. Now can we write this? We have the equation what? 9 to the power of n plus 1 minus 8n minus 9, right? We have this equation. Now for a is equal to 8, if you substitute a is equal to 8 and this, not a, sorry, x. For x is equal to 8, if you substitute, because we need to get here 9, right? And n is equal to, if you want to substitute, we can substitute what? N plus 1. Or okay, n everywhere it is n, so let me erase it here. Yes, we have been using n multiple times. So instead of n, let's write m. Is the same, right? You write m, n, doesn't matter. Fine. Any problem, anyone? Because see, I'm just replacing because n is also here. That's why. Okay. And there will be confusion. Sorry. That's why I'm writing like that. Okay. So we can replace this m is equal to n plus 1, so that we can get this. Okay. You see, if you substitute this and this in this equation, what you will get? You will get this one, right? So let's substitute this here. Let's say this is equation number 1, 2. Substitute 2 in 1. Okay, so what we'll get 1 plus 8 to the power of n plus 1. That's what we will get. So this we can write n plus 1 C0 plus n plus 1 C1 into 8 plus n plus 1 C2, 8 square, and so on up to the last term will be n plus 1 C n plus 1, 8 to the power of n plus 1. We have used this, right? Is there any problem till so far? We are using the same formula. That means this we can write this 9 to the power of n plus 1 is equal to 9 to the power of n plus 1. How, what we can write? N C0 n plus 1. N plus 1 C0 is how much? Anyone? N plus 1 C0 is how much?
Sorry, one n plus so one second, sorry,
See, anything x,
n plus 1.
yeah, x plus 1 plus k C0 is always equal to 1. Anything combination, 0 combination is always 1. C is combination, right? We will study that in permutation and combination. So that's what anything combination 0 is 1. Only if you have 0 combination, that means you have only one output. It's very practical. Okay. So n plus 1 C0 is always equal to 1. Okay. Plus, we have written it here. Okay, this one. Fine. Now after this plus n plus 1 C1 will be how much? It will be n plus 1.
Yes, sir.
Okay, you have to do that. You cannot remember everything. You just need to do this subject. NCR is equal to n factorial upon r factorial n minus r factorial. Okay, and if you plus add 1, so you just add 1 everywhere. That's it. Okay, got it? All right. So this plus 8 plus n plus 1 C2 will be how much? Huh? Anyone? Nidhi? N plus 1 C2 will be how much? No one. Okay. Or anyone is there? Whatever the values. Okay, let's. So can we take this 8 square after this? The term will be n plus 1 C3 8 cube, right? Like that, the term will go on, right? Yes. Isn't it? The next term will be n. Yes or no? Anybody is getting or not? Anybody is having doubt, anything, please tell me.
No, sir.
You understood everything?
So far, yes, sir.
So, so what I'm doing, see, we have written these two terms. Now, why we are writing, I'll tell you. Now, after this terms, after all terms, what we are taking 8 square as common. Okay, 8 square, if you take common, what will remain? N plus 1 C2 plus what else? In next, it will be n plus 1 C3 into 8 and plus so on. And at last, what we'll have? N plus 1 C n plus 1 8 to the power of n minus 1. Because 1 8 you are taking common, 8 square you are taking common, right? So these terms will be in common. Why we have written it like that? Because we needed only this much to prove, because we need to prove this. Okay, that's why we needed this much, and we need to prove it a multiple of 8 square, that is 64. So let's write it again. 9 to the power of n plus 1 is equal to 1 plus, what can we write this? This is 8n plus 8, fine, plus 8 to the power of 8 square is how much? 64. And here this all multiple. See, whatever this is, it will always give a natural number, right? So can we write that as k? K is some natural number, we don't know. Now you take this one to the left hand side, what you will get? 9 to the power of n plus 1 minus 8n. 8 plus 1 is 9 minus 9 is equal to 64 into some value k. K is a natural number which we don't know. Okay, that means we have proved that this, the left hand side, n to the power, n 9 to the power of n plus 1 minus 8n minus 9 is a multiple of 64. It is 64 into k, right? So that means it's a multiple of 64, hence proved. Anybody is having doubt in this proof or in this step? I can understand the doubt because you haven't done the mathematical induction. So please tell me if you have doubt, we can proceed. And don't worry, you whatever the problems will be there of these type of proofs, it will always end up like that. Okay, because it has to, otherwise it cannot be proved. Okay, so whatever problems you will face, you will always use this same method. Do one thing, try to prove this question number. Okay, what is that? In exercise, do we have any questions like that? Examples? Okay, try to do question example 4 of page number 168. Example 4, page number 166. Got it? Just try to solve yourself. Don't just copy it. Otherwise, we won't learn. It's the same problem, same type of problem it is. See, all the problems that is there in the exercise, it will always, you will have some solved example problem. Like Murli, you could have seen example 3. Okay, example 3. I think we have done that also in class, right?
Yes, sir.
Okay. Example 3, I think we haven't done it, but you can see example 3. It's a really nice question. Example 3. Okay. It's just binomial. See, so just binomial expansion. You just need to understand binomial expansion and you can do it. You can solve it. I don't know if binomial theorem is proved here in your book in NCERT. Yeah, it's binomial theorem in page number 163. See, there is proof. Okay, and that proof is based on mathematical induction. That's why you should not have left that chapter. Anyway, the question is compute 98 to the power of 5. So that's also done like that. Same method that we did. So you will try to prove this question number 14 in your that as homework. Okay, and I think we have some observations. So let me write those. from binomial theorem, of course. So from binomial theorem, what we can write is a plus b to the power of n. This is, and we expand the binomial expansion. So how do we do that? We write nc0, a to the power of n, b to the power of 0, plus nc1, a to the power of n minus 1, b to the power of 1, and so on. And the last term we write as ncn, a to the power of n minus n, sorry, n minus n, b to the power of n. Now you see here what we are doing. We are writing the power NCR, we are writing here, and here we are writing n minus r. So r here is 0, so n minus 0 is n. R here is 1. So from here we can write this will be equal to summation. We can add this summation nck, okay, nck a to the power of n minus k, b to the power of k, okay, and k varies from 0 to n. Can we write like this? We are just adding up all the terms, and in short we can write like that, okay. Yeah.
Yes, sir.
So this is called your binomial coefficient. Okay. So done. This problem, example 4. Are you done? Everyone, please tell me so that we can move forward. Ajay, tell me, those who are listening, please tell me, how many terms are there in this? How many terms are there? Do you know what the meaning? What is the meaning of term? This is first term, this is second term, and this is your last term, right? In between you have a lot of terms. So whenever it is a plus b to the power of n, so how many terms will be there in binomial expansion? So that means how many terms this will contain? Huh? Anyone?
Sir, n plus
N.
1.
N plus y, n plus 1 is it?
Sir, because NC0 is first term and the last term will be NCN. So
Yes, exactly.
we have N
Okay,
plus 1.
okay, okay, Nidhi, your voice is not clear. So this will contain n plus 1 term. Okay, n plus 1 number of terms. So a plus b to the power of n will contain n plus 1 terms, right? Like I'll just give you example, like a plus b whole square. Okay, so n is equal to 2 here. What do you write? A square plus b square plus 2ab, right? How many terms are there? 1, 2, 3, right? 1, 2, 3. A plus b cube. Let's write that. So what is this? A cube plus 3a square b plus 3ab square plus b cube, right? How many terms are there? 1, 2, 3, 4. So 4 terms are there. What is the value of n here? N is equal to 3. So always, whenever you have an expansion, so from here also you can write a n this n plus, sorry, a plus b to the power of n will contain n plus 1 terms. It will always contain one more term to this indices. Okay. Now using this concept, we can find the general and the middle term. Okay, so general term of binomial theorem. So what do you mean by general term? See, whenever you are writing this binomial expansion, like here, a, this one we have written, right? A plus b to the power of n, and we summarized it as this. Okay, that means you just, in general term, you can just substitute the value of k and you will get any term you want. Like the first term, if you want, you just substitute k is equal to 0. So you'll get the first term. If you substitute k is equal to 1, you'll get the second term. K is equal to 2, you'll get the third term. That's why that term is called general term. Okay, so general term can be written as like for a plus b to the power of n, general term, for this general term can be written as NCR, okay, a to the power of n minus r and b to the power of r. Okay, that's how you write. Now from here, tell me what is n plus 1, tell me m plus 1 term. Find m plus 1 term. Jeffrey, tell me what is m plus 1 term. Hari Raghav. How you will find m plus 1 term? Hari Raghav. Murli. Murli, how you? Yeah, tell me. You just replace r by m plus 1. That's it. That's what you need. This is a general term. This is the rth term. That's why it is called general term. Okay, and replace, you can write NCM also if you want. It doesn't matter. Okay, it is a general term. You can write anything. You know the meaning of general, right?
Yes, sir.
So just replace NCM plus 1 e to the power of n minus m plus 1. Okay, b to the power of m plus 1. That's it. Or this, Jeffrey, you tell me, find n minus 1th term.
So 1 minute.
Everyone find out this. Got it?
So no.
You just just replace r by n minus 1. That's it. So you know the general term is NCR, a to the power of n minus r, b to the power of r is the general term. Okay. Now replace this. Do that. So this will become n. Anyone can tell me the answer? Can anyone tell me the answer?
Sir, NC n minus 1.
Okay, wait. Raghav, are you there or not? Hari Raghav.
Yes, sir.
So why you were not answering when I asked you the first time? Okay, Naveen. Naveen, you are there? There is no point asking. Huh? I want you to learn, but you guys are not. Okay, fine. Abhinav, can you tell me?
1 second, sir.
Yeah. You just replace r by n-1. That's it. 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 That's it Do it fast. We have to do a few more things. How much time you want here?
Sir, it's
Yes.
T plus 1. A power minus 1.
Okay, Nidhi, got it. Your audio is not right. So let's. So this will become NCN minus 1 e to the power of n minus n plus 1 b to the power of n minus 1. So again, this will n factorial divided by n minus 1 factorial n minus 1 factorial e to the power of, so this will get cancelled, this will be 1 b to the power of n minus 1. Now let's solve this one. So this is n factorial whole divided by n minus 1 factorial. So in the numerator we can also write n into n minus 1 factorial, n multiplied by n minus 1 factorial. Okay, this will be equal to n minus n plus 1 factorial. So this will get cancelled. So this is ultimately 1 factorial. This will get cancelled. Okay, this is a to the power of 1, b to the power of n minus 1. So this is n factorial upon 1, n upon 1. So this is n to the power n a b to the power of n minus 1. That's what I just wanted. This is the n minus 1 term. That's it. Okay. Got it? Yes? Okay. So this is the use of general term. You should learn about factorials. Okay. I think still you guys are not comfortable with this. How to solve these. Okay, how to solve these. You have to do it. And this is not that tough that you cannot do. You can obviously do it. And if you need help, please let me know. See, this is how we write a general term. Okay, this is the general term that we write. Now let's understand this thing. Before moving ahead, let's understand one more concept. Okay, now let's say in some a plus, let's say you have an equation or an expression. You have x is, what is this, x square plus x to the power of 5 plus 4x cube minus 3x square plus 1. How many terms are there? Huh?
4 terms, sir.
4 terms are there. Okay, if I'll include one more, minus, let's say alpha x to the power of 4. How many terms are there?
5 terms, sir.
Okay, 5 terms are there. Okay, so this is, and if I ask you here, which one is the middle term, how you will find out? First, you will arrange, yeah, no, first you will arrange this above expression in decreasing power. Okay, x to the power of 5. Now you will write this minus alpha x to the power of 4 plus 4x cube minus 3x square plus 1. So this is what it is. Now, if you want to find middle term, that means same number of terms should be from forward. And if you go backward as well, you will get same number of terms. Okay. So from forward, one term you cancel, one term, 2. So only this one is left. So this is your middle term. That's how we decide, no? Who is in the middle.
Yes, sir.
Right? That, like, if you if you have 5 boxes, or let's say these many boxes you have. Okay, I don't know how many, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you have 9 boxes, and if I ask you in the middle box, you have gold. So which box you will open? Box number
5, sir.
5, obviously, right? So that's the box in which you think gold is there, right? Or at least I told you the gold is. But if I tell you Okay, I'll give you 1, 2, 3, 4, 5, 6, 7, 8 boxes. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Now, if I tell you, in the middle box, you have a gold. You have gold in middle box. So which box you will open?
So 4 and 5.
4 and 5 is in the middle, right? So here you see the probability is 100% finding gold, right? Probability is 100% because only one box is there. Here you have to open 2 boxes. That means probability is 50%. If I ask you, if I say you that only one box you can open, that means your probability is how much? 50%, because you know only 2 middle terms are there. Two are the box which are in the middle. So when, like similarly, whenever you expand the binomial theorem, we are not studying probability, but make sure that in probability also these type of problems are there. Like only if you'll go to that JE level, otherwise obviously it is not there. So I won't go that far. 100%, not 100%. That means if you have even number of terms in a expansion, suppose there is expansion a plus b to the power of n. Okay, we don't know the value of n, right? And you have like odd number of terms. So odd number of terms means let's say the value of n is something, and you get total 9 terms or 11 terms or 13 terms or 51 terms. That means these are odd terms, odd number of terms, right? Yes? Yes or no?
So yes, sir.
Yes.
Okay. So if you have odd number of terms, so how you will find the middle term? Which one will be the middle term? See, how do we find middle terms? Let's again come here. So in this one, let's say here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 terms, 9 boxes total, right? And you said 5 is the middle one. How do you do that mathematically? You add 1 here, right? You add 1 and divide whole by 2, right? So that's what you did. So you added 9 plus 1, that is 10, and divided it by 2. What you got? 5, right? That's why you said 5 is the middle term when number of terms are odd. Okay, if number of terms are odd, that means you will add 1 more. So how many are there? N plus 1. How many terms are there? N plus 1 terms. Total n plus 1 terms are there, na? We saw here. See where it is. A plus b to the power of n will contain, a plus b will contain how many? N plus 1 terms, right? If the power is n, it will contain n plus 1 terms. So if the power is, let's say, Jeffrey, you tell me, if a plus b to the power of 7, how many terms it will contain? Huh? Jeffrey, are you listening? Are you even listening there in the class or not? Nidhi, how many terms it will contain? Hari?
8.
8 it will contain. N plus 1, that is 7 plus 1. That is 8 terms. If a plus b to the power of, let's say, alpha, how many terms it will contain? Hari? It
N
is
plus alpha.
alpha plus 1, it will contain plus 1. You just add 1. So if it has a or 1 plus x to the power of 51, how many terms it will contain? 52, right? Total it will contain 52 terms. Just turn on your mic and speak something. Just don't sit like an idol. Okay. So now you see, if odd number of terms are there, that means n is even, right? If n is even, that means there will be odd number of terms because you add 1 in it, right? Okay, let me write here. If in a plus b to the power of n, if n is even, it will contain how many terms? N plus 1, which is odd number of terms. Odd number of terms. Okay. Got it? That means for the number of terms to be odd, the power need to be even, like a plus b square. How many terms are there? A square plus 2ab plus b square. So 1, 2, 3, odd number of terms. 1, 2, 3. See, the power is even, and how many terms it is containing? 3. That means odd number of terms it will contain. Got it? Okay. Now, how do you find the middle term? So middle term, what we discussed here, we just add 1 in it and divide it by 2. Okay. So total number of terms. Now, if in a plus b, sorry, my mistake. Here, if n is even, it will contain n plus 1 terms. That means that is odd number of terms. So from here we can write the middle term how we can write the middle term. We'll just add 1, n plus 1 plus 1 divided by 2. That's what we did now here. See, that's what we did. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. So we add 9 plus 1 divided by 2. That's how we got 5. Okay. Yes. So that's how we can write n plus. So the middle term will be n plus 2 divided by 2. So n by 2 plus 1 also you can write. So this is the middle term. So in an expansion with is the middle term. If n is even. Okay. If n is even, this is the middle term. Anyone is having doubt? Because if here, where is this? If n is even, what will happen? It will contain odd number of terms. Okay, because the total number of terms will be n plus 1. If n is even, let's say 2. So it will contain 2 plus 1, that is 3 terms. And 3 is the odd number. So for odd terms, what we can do, we can just add 3 plus 1 divided by 2. That's how we'll get the middle term, that is 2, right? Okay, find question. Do this. Find the middle term in x minus 1, okay, x plus 1 to the power of 4. Do it. Find the middle term. Or x plus 1 to the power of 14. Instead of 4, just write 14. So how do you find the middle term? This you will just add 14 plus 1, right? 14 by 2, sorry. 14 by 2 plus 1. So that is 8th term. So how do you find the 8th term? Finding 8th term in x plus 1 to the power of 14. So first we need to write the general term. What is general term? NCR x to the power of r and 1 to the power of, sorry, x to the power of n minus r. N is 14, so let's write. Let's write the general term. NCR here a to the power of n minus r, b to the power of r. So this is a general term. Now for here, n is equal to 14, r is equal to 8. That's what we have got. Okay. A is equal to x, b is equal to 1. So just substitute it. 14C8. A is what? Sorry, A is x, x to the power of 14 minus 8. B is 1 to the power of R 8. Right, so you need to find this. So this is 14 factorial upon 8 factorial and 14 minus 8 factorial. This is x to the power of how much? 6. Okay, so this will be 14. Now you just need to solve this. 14 factorial upon 8 factorial multiplied by 6 factorial, x to the power of 6. So this is the middle term. Middle term in the given expansion. That means x plus 1 to the power of 14. Okay, this one I have done. You solve this one. Question. Okay. Find middle term. Middle term in okay. 1 minus y to the power of 72. Did you understand or do you need any help or anything? You can ask. Jeffrey, you understood this one, first one? See, first always first n by 2 plus 1 if n is even. See here, n is even.
Yes.
Right? So how do you find the middle term? N by 2 plus 1. Okay. So n by 2 plus 1, if I'm doing n by 2 plus 1. So what we got? 8. That means we need to find the 8th term. So to find the 8th term, first we need to write the general term. So general term is, this is general term in a plus b to the power of n. So general term is NCR, a to the power of n minus r, b to the power of r. Now if you compare these two, okay, and you need to find the 8th term, remember, that means r is equal to 8. That means what you can say, n is equal to 14, r, that means n is 14, it is already given, right? B, a value is x, b is 1, and we need to find 8th term, right? That's what we have calculated, 8th term. So we'll just substitute these values in the general term and we can find it. So if you substitute, that means you'll get the middle term. So similarly, find this one. So see, again here it is even, right? Again n is equal to even. So which one will be the middle term? Jeffrey?
10 by 2.
Tell me which one will be the middle term here?
Sir, for this 37th term.
30?
7th term.
37th. Okay. 37th term will be the middle term because 72 divided by 2 plus 1. So we are middle term will be this. So how much is that? 36 plus 1, that is 37. You need to find 37th term. Tell me the general term, Hari. Sunshine.
Sir,
Sunshine. Tell me the general term. Sunshine. There or left?
Hear me, sir.
Okay. Tell me the general term. Yes, sir. Please tell me. See, this is the general term. Now tell me. NCR a to the power of n minus r, b to the power of r. Now, tell me what is n? N here, n is equal to what? N is equal to? What is n?
N, sir.
N is how much? N is 72, no? See?
72.
N is 72. R is how much? R is the term that you are finding. So 37. A is what? 1. B is what? Got it?
Sir, yes, sir.
Just find out now. Find this. Oof. You just need to substitute there. That means you need to find out N is 72, C 37. A is what? What is A here?
A is 1.
1. Okay, 1 to the power of anything will be 1. Okay, B to the power of minus B is minus Y to the power of what? R. R is 37. So it will be a negative term, right? Because minus 1 to the power of any negative, any
odd number, sir.
Yeah, it will be negative, right? Yes, correct. So this term is going to be negative. The middle term is negative. So this will be equal to minus 72 factorial upon 37 factorial. 72 minus 37 factorial. Okay, and y to the power of 37. That's
37, sir. Minus y to the power 37.
yeah. No, minus I have already taken out here.
Sir, I did not. Sir. Okay, sir.
Okay, see, minus y to the power of 37, you can write as minus 1 to the power of 37 into y to the power of 37. Okay, so minus 1 to the power of 37 will become minus 1 multiplied by y to the power of 37, which ultimately will be minus y to the power of 37. Fine. I don't think there should be any doubt. Okay, so we'll end the class here. Okay, it's already been too much. See, we have done for even if the power is even, like we have done for terms like a plus b to the square, a plus b to the power 4, a plus b power 6. We know there we have how many 3 terms, 5 terms, and if it is 6, so it will be 7 terms. That means number of terms are odd. So you know which one will be the middle term. So middle term will be the second term. Here the middle term will be the third term. Sorry, which term it will be? Yeah, third term. Here the middle term will be which one? Fourth term, right? I suppose. Yeah, fourth term. Yeah. So you see, we have done for only if n is equal to even. The next class we'll do n is equal to odd. If n is equal to odd, so how do we, if n is equal to odd, like a plus b or a plus b cube or a plus b to the power 5. That means number of terms is how much? Here the 1 term is there. Here how many terms are there? 4. Here how many terms will be? So sorry, here it will be 2, no? 2. Here how many terms? It will be 6. Now that means how do you find the middle term? 1, 2, 3, 4. 4 boxes are there. That means these two will be the middle one. 1, 2, 3, 4, 5, 6. So which will be the middle one? These two will be the middle one. So we'll learn how to find these in next class. Okay. So your homework, you just try to do. It will take another class and we'll be done with this binomial theorem, and we'll take one more class for discussion, discussing all the problems if you have doubts. Okay. See, find let's say example 5 you do. So in example 5, you have to find in 2a plus 2 to the power of, it is given 50, and you have to find 17th term and 18th term. Okay, that means r is equal to 17 and r is equal to 18. You need to find these two. Whatever term you need to find, that is the like when you are writing the general term, NCR a to the power of n minus r b to the power of r. That means you are writing actually the rth term. Okay, this is also the rth term you are writing. So if you have to find the 17th term, that means you will replace r by 17. If you need to find 18th term, you will replace R by 18. That's it. Okay. I hope you understood this thing.
Sir.
And yeah, example 5. Okay. Okay. And in exercise 8.2, find question number 1, 2, 3, 4, 5, 6, 5, 6, yeah, 6, 8, bus 5, 6, 8. Till this far you do. Okay. 1,
Okay,
2,
sir.
3, 4, 5, 6, 8. Yeah. So most probably we'll have one more class because yesterday I wasn't there, but we'll have one more mathematics class if I'll try to finish this binomial theorem. Okay, because you need to study permutation and combination, right? See, in binomial theorem, mostly calculations are there. Okay, if you just know the formula, you just need to calculate. That's it. Okay, in permutation and combination, we'll have to use, greater percentage of our brain. That's what I'll say. Okay, permutation, you have to think a little bit in permutation and combination. That is very logical chapter, permutation and combination. Very, very important. This is very important for probability as well. Okay, so if you are good in permutation combination, you will be very good in probability. Okay, so with this, I'll end today's class. Thank you very much.
Thank you, sir.